Hey, conceptual physics students, how about a few hints regarding the textbook assignment on chapters 6, 7, and 8? It seems like a lot of information, all three chapters, but there aren't that many problems and they have a lot of similarities. So first of all, let's look at number 14. Now, this won't be all the problems, but a few of them. Number 14 in the chapter 16, or the chapter 6 assignment. So for number 14, understand one tiny hint. When they say ratio, ratio always means to divide. So the ratio of two things means to divide one by another. So let's look at now number 27. So number 27 on page 101, you want the acceleration of the jumbo jet. Okay, you are going to use F equals ma to find that. And then it's pretty straightforward. There aren't a lot of knowns and unknowns. So F equals ma is very useful. Let's look at number 30 on that same page. Again, you're going to use F equals ma. The important feature here for number 30 is they give you the following information. They tell you that the acceleration is 1.5 or 1.8 times g. Now you remember that g is the acceleration of gravity, which is 9.8 meters per second squared. So basically what they're doing is they're telling you the acceleration is 1.8 times that acceleration due to gravity. Then the rest of it is pretty straightforward on number 30. Let's look at number 60. For number 60, first, we have to find the acceleration. Now remember, to find the acceleration, we've done this before in the previous unit. To find the acceleration, it's very useful to write the knowns and unknowns. So just to give you a little hint, what I do is, remember, I always put a equals question mark because that's what I'm solving for. The v1 is 22.0 meter per second, the v2 is 0, and the time is 4.0 seconds. You're searching for a formula that has just those. When you find that formula, then it's a simple matter of using F equals ma to finish it. And that is number 60. Little hint. Let's look at number 67. On number 67, we're going to do the reverse of what you just did. Now, so in number 60, we used acceleration and that helped us find the net force in F equals ma. This time, we're going to start with F equals ma. So solve this for the acceleration by using algebra, what they give you. And once you have the acceleration, then you can make a list of the knowns and the unknown to find d equals question mark, like we've done many times in chapter 4. I think that's going to help. Let's look at chapter 8. And I'd like to start with number 58. That would be on page 142, I believe. And so remember, when things are crashing together, that's conservation of momentum. Conservation of momentum has special formula for inelastic. Whenever you have things crashing, the left-hand side is before the crash. The right-hand side is after the crash. So in all of the inelastic collisions where they stick together, after the crash, they are together one mass. That's why I put them together. Remember, the prime means after. So what I'm pointing to, the v prime, means the velocity of the two combined after the crash. That's number 58. Let's look at number 60. So number 60 is involving a force. So I want to remind you that impulse is the same as the change in momentum. What I've given you on your formula sheet, I believe, is a very good formula for impulse, the left-hand side, equals mass times v prime minus mass times v. So the right-hand side is the change in momentum. It's the momentum at the end minus the momentum at the beginning. Remember, v prime stands for the velocity at the very end. Let's look at number 65. Okay, number 65, again, is another collision inelastic. m1v1 plus m2v2, that's the momentum before the crash. Afterwards, they are stuck together. That's why the masses go within the one parenthesis. One trick on 65, watch this very carefully. Direction matters. Direction is important. We use positives and negatives many times for direction. I think this will help significantly. I hope you have a good day.